First milestone, Will, we got the projector to work, so here we go. So this is the first time I've done a talk, so of course that would blow up right before I start it. A little bit about me. I'm a network engineer. I've been doing that almost 10 years now. I've always had an interest in security and kind of dabbled. I've got my OSCP, run a small blog with a few other people, and hang out in IRC channels and try to learn as much as I can. I'm doing this talk mainly because after 10 years of implementing systems, you start to see a lot of repetitive things configured incorrectly that really can lead to some serious security problems. I really only picked 5 that to go over, but what I'm going to do is basically go over what the configuration is, why it's commonly done that way, how the attack works. I'll give you a demo of the attack, which I pre-recorded all the demos because I didn't want something like this to happen and I wouldn't be able to do them. And then I'll go over mitigation steps, ways that you can prevent the effectiveness of the attack or maybe even prevent the attack altogether. There are some things that I'm not going to do a demo of or really spend a whole lot of time on because they don't need their own demo. Weak passwords. I don't know how many law firms I've worked for that their passwords are law. You know, that's pretty common. Wide open firewall rules. I see one of the things that I do for my company is network assessments, and we not necessarily from the security side, but we go through the network and look for misconfigurations and things like that more on an infrastructure level. And I would say 80% of the time at least we review the firewall rules and find an open RDP rule that just allows anybody to RDP to their external IP and hit one of their internal servers. Passwords stored insecurely. You still see passwords taped to monitors, keyboards, stored in text files, printed out on somebody's desk, every password for the whole organization. Open Wi-Fi, that's a fun one. A little bit of a story about that. I had a client that dealt a lot with, they were a distributor. They distributed 3M products and things like that. And they had a wireless system in their warehouse that was specifically for handheld scanner guns. And the Wi-Fi system ran WEP encryption because the scanner guns didn't support WEP. The problem is they also had a separate wireless network that ran WPA, which is obviously much more secure than WEP, but they were all in the same LAN. So if you connected to the WEP network, you were on the same network as if you connected to the WPA network. So it kind of had a chuckle about that, and after I showed them the downside to that, they quickly got rid of that WEP network. Shared accounts, I've seen many times that companies just have, a front desk account that 10 different people use. Lack of awareness. I don't know how many times, so part of doing these network assessments is we go into the client site, we go around to each computer, we install a small agent that collects warranty information, it collects system stuff like that for our report. I don't know how many times I've walked right past the secretary, walked around the place, installed my agents, went into the server room, installed agents on their servers, and nobody asked me a single question of who I was, asked for any sort of verification of who I was. They just acted like, you act like you belong, and 90% of the time nobody's going to ask any different. So that was kind of eye-opening. I walked into the CEO's office after the fact and was like, you might want to talk to the receptionist about this, because they did have a reception area with a door that separated the reception area from the rest of the building, but it wasn't locked, and if you walked right through, she just waved to you and said good morning. So that was polite of her, as I was, could have been stealing all their information. But so the first thing I'm going to go over that I see, believe it or not, quite often are my slides showing? Yeah, they are. Windows administrator, password, GPO, local admin password, GPO. There used to be, up until Server 2012, you were able to set a group policy that would basically give you the ability to set the local administrator password on all the machines in your network. A lot of companies do it because if you've got 400 endpoints, it's a lot easier to have a group policy set the local admin password so you always know how to log in to the system, or you always have credentials. If the domain trust gets broken or anything like that, you need to have some sort of way to get back in to fix that trust. I'm kind of going over a little of this already, but it also makes changing that password easy. If you have somebody leave and you need to change your local admin passwords, having that GPO does make things more simple for an administrator. The issue with it is Microsoft actually released the basically the hashing algorithm that they use to hash that password stored in the group policy is very weak, and it's easy to decrypt. There's actually a PowerShell script you can run to decrypt the encrypted password. So I'll this demo is like sped right up, so I might pause it a couple times. So I'm logged in on this machine as a local, a limited user that I named limited user for, ease of explanation. What I'm going to do here is just show that I can't access any of the local system accounts. So I wasn't able to get into the local admin folder. I'm going to do a sysinfo here just to show the name of the domain controller. So the domain controller is CTFSCCM. And if you browse to the location in the group policies folder where that specific group policy is stored, you'll find a groups XML file, and in that file is a hash that equals the value of the local admin password for your system. So the hash is actually right there. So what I will do is switch over to another Windows machine, and you save that out as user.txt, whatever you want to call it, groups.txt. And there's a PowerShell script that you can run if I could type when I record this. And it decrypts the password. And from that point, you have local access to basically any machine that policy applies to on that network. One thing I wanted to include in this recording, and all I'm going to do here is log off and log in as admin to show that it worked, or that was the actual password. One thing I wanted to add to this demo that I didn't, and I tried to do it from the hotel room and it fought me, so. But I wanted to add the Mimikatz attack on top of this, which is basically a way that you can leverage cache credentials on a Windows machine to pull sometimes unencrypted passwords right out of the system. So if a domain admin logged into the system to set it up and you run like Mimikatz, and there's a few other tools I think that you can use also, but it'll potentially pull the domain admin password out of the system also if it's cached in there. So mitigation, don't use it. Some places I've seen that are using it, they would set it up when they were deploying a batch of machines, apply it to the group of machines they were deploying so that the policy would take effect, and then they would disable it. You can do that. There are third-party solutions for managing passwords on systems. Obviously, you want to do your research and make sure the one you choose doesn't have its own vulnerability that is equal or worse to this one. And like I said, it has been disabled in Server 2012, so but I haven't seen a whole widespread deployment of a lot of Server 2012 domain controllers yet. So it's still available if you're using 2008 R2 at this point. Databases running as SA is kind of the next part of this that I want to go over. And not necessarily just running as SA, but also the SQL services running as system. A lot of the times I see vendors come in and their stance on it is they just want the application to work. So most vendors will tell you they want their application to have SA rights. They want you know, the application to have all the permissions they want, because they don't want to have to fight with permissions. They don't want an application error to come up and have it come back down to permissions. And a lot of the time it's just because, you know, it's trickling down from somebody else telling them that that's how it needs to run. But I've seen everything from, you know, inventory control systems running as SA and system to medical record systems running as SA and system. And granted, you'd have to find a vulnerability in those systems to leverage that. But if you do a Google search, you can pretty much find a vulnerability in most applications at this point. So the specific attack I'm going to go over, there's a whole bunch of issues with databases running as privileged users and things like that. But the one I'm going to go over is SQL injection, because that's kind of a really common one. SQL injection for me is kind of has always been kind of tricky. So whenever I have to do it, I usually let my daughter pound on the keys a little bit and see what she comes up with. 90% of the time it works. So, you know. But so in my demo, I'm going to locate SQL injection. We're going to enable the XP-CMD shell stored procedure on the SQL server. We'll create local administrator username and password on the server, and we will enable remote desktop via SQL injection, and then we'll log in. I don't know if that's going to be big enough to see. So what I did here is I just did an Nmap scan so you can see that 3389 is not enabled on this machine, and obviously port 80 is. And I'm showing here that it does work. You can log in admin as the username and password just to get access. I was lazy and I didn't put a logout feature in the application when I created it, so I was just clearing my cache to kill the session. And if you try to log in with something that doesn't work, it just doesn't go anywhere. So what I had showed there, and oops, that figures. So that was showing that if you logged in as a non-existent user, it wasn't going to do anything. And I just clicked again. When it said query failed, what I did is I put a single tick in, which kind of is standard for detecting SQL injection. And what I'm going to do now is a pretty standard tick or 1=1 query, which basically bypasses the login to the application. So that shows us that SQL injection is possible in the application. And I actually cheated on my demo here because I had notes of different things I could do. So the first set of commands I'm going to run through this are basically enabling the XP-CMD shell stored procedure. And there's like 4 lines you have to do. You have to enable advanced options and then run the reconfigure in SQL syntax for it to be recognized, and then you can actually enable XP-CMD shell. And what this does is, you know, pretty self-explanatory, but it's enabling Windows commands to be executed via the SQL database. So it's literally as if you ran cmd.exe and started executing commands. One thing I'll show here real quick is that I am executing commands, and I'm going to do a ping, and I'll actually output it to the directory that basically to the web root so that you can see it. So you'll notice that this delays, and the reason it's delaying is because the ping is actually happening. So after 4 pings, that's when it loaded the page. And if you browse to where I told it to save the output, you can see the ping that it executed. So ping is obviously pretty non-malicious, but it was just a way to demo that it was working. So the next set of commands that I am going to do is create a local user on the system. And that's just by using the standard net user command. Then we'll make that user a local admin using the net local group command. Guess I should sped this video up a little. I'm not clicking though because I'll have to start over again. And then at this point, we'll enable remote desktop on the system, which essentially you're using the XPCMD shell to execute a regedit that enables the term service, and then from there you will use the net service command to bounce the term service, and that will actually enable it. Because if you change the registry and don't bounce the service or start the service, it won't actually show as enabled when you try to do a port scan or anything like that, because it's not running. And obviously this application I wrote with zero input validation or cleaning or anything like that. It's designed to be exploitable. There are things you can do, obviously, to mitigate that and not accept a standard tick where 1 equals 1 in your input. Right here I just showed that 3389 was then open, and I'll remote desktop to it. So that's a pretty simple demo of SQL injection, but and there's 1,000 different things you can do with injection other than just creating a user and enabling remote desktop. But it was just a simple one, quick and easy. So log in localhost with the hacker user that we created, and it's logging in. And from there, again, you might even be able to use the mini credentials to escalate from there. But keep in mind that that's the actual SQL server, so you have access at the local admin access at that point to the database server. You could potentially get into the database, extract data. So if you're talking, health records, you're talking a payment system, you're at that point able to extract any data that database holds and any other database on that system. Mitigation for that, access control, give the application what it needs to run, work with the developers if you can to find out what they need for permissions and not give them anything more that they don't. Don't run the SQL service as a system, because that actually will allow you to enable XPCMD shell and run a lot of those commands that you really shouldn't be able to run. Keep up to date on patches for your application. If it's a homegrown application, meaning in-house, your company built it, have code audits done regularly to make sure that as the application matures, that new vulnerabilities aren't being introduced. Code audits won't always catch 100% of everything, but it's better than nothing. So that's definitely, one of the things that I would recommend there, and most people don't do it, unfortunately. So Wi-Fi I'm going to talk about. My demo blew up for Wi-Fi, so I don't have a good demo for it, but I will talk about what I meant to say when it came to what I meant to show when it came to Wi-Fi. Wireless misconfigurations are really common. I still see WEP everywhere, open wireless. You still see the WPA key being the name of the company. I've seen the WPA key be A, B, C, D, E, F, G, H, I, crazy stuff that just doesn't even make sense. And there's a lot of easy ways now to attack that. You can capture the hash of the handshake for WPA, and you can crack it using various different tools. WEP can be cracked now in a minute, probably less than a minute, depending on if it's a shorter key. And a lot of the times, it can be aging hardware. There's a bunch of stuff coming out right now with the whole, embedded device research and things like that, where people are finding vulnerabilities in the core, the actual access point itself. There's a open management port on the system that has a default password or all kinds of different things like that. So keeping up to date on software revisions and making sure that you don't have ancient hardware running in your infrastructure, and sometimes even the new stuff has it, so you got to be careful there. Convenience is a huge thing. WPS is another attack vector where you can pretty much brute force the WPS pin that is used to connect to the wireless network. So, you know, a lot of people like being able to push that little button and connect to their wireless, but they don't realize that they're also leaving themselves open for attack. Guest access is another thing. Guest access is great, except for the amount of times that I've seen guest access that sits on the same network as the corporate wireless. That doesn't do you a whole lot of good if you're not segmenting that traffic, and you're allowing your unprotected guest network to access your servers anyway. So what I was actually planning to do a demo of wasn't really web cracking, WPA or WPS, because you can find a bunch of those. I was actually going to do a mana karma type attack, which is basically where you stand up an access point that will pretend to be an access point you've already connected to, and basically, if you're sitting there on your phone, it'll just automatically connect to an access point you've told it to connect to before, and you won't really know any better unless you went into your settings and saw on your phone that you were connected to an access point that really shouldn't be in the area that you're in. And from there, you're actually man-in-the-middling the wireless connection. So if you go to your bank site, you can run SSL strip, which will actually take the security away from the session and allow you to sniff the passwords, clear text. You can steal cookies for session connections. Pretty much anything. You're in the middle of the session, so you can control what happens to that user's data as they go through that connection. There's my demo, which clearly is, yeah, it's great. Mitigation. Secure your network with the strongest encryption you can. Like I said, we made that company, we didn't make them, but we highly encourage them to upgrade their handheld devices to support a stronger encryption than web. The second recommendation to that, if they couldn't change that, was to segment the network, whether you do VLANing or however you want to do it, but just try to mitigate what somebody could do if they got onto that web secured network. Yeah. And train users on what to look for. That was kind of what the point of the karma attack was going to be, was to kind of show users that if you're at your work and your phone says it's connected to your house network, there's probably something weird going on there, unless you brought it with you. Bear with me too, because I had a bunch of notes that I don't have now because we had projector issues. But the fourth thing that I actually see a lot is VLAN hopping. Not that I see it happen, but I see networks that are vulnerable to VLAN hopping. And it's really, a lot of the time, caused more because people don't know that it can happen. And by default, a lot of your switch manufacturers will ship their devices with settings that allow this to happen natively. One of those is if your switch will automatically negotiate a trunk, which is the dynamic trunking protocol. If your switch will do that out of the box, it could be potentially vulnerable to VLAN hopping. And the other thing you can do is actually double tag your packet. So if you're trying to do a malicious attack, you actually can tag the packet with the native VLAN that you're on, and you can and then you tag it with the VLAN you want to hop to. And what happens is after you hit the switch the first time, that tag is stripped off, and then you're passed into the VLAN that you're trying to hop over to. So my demo for this is pretty basic, but basically I have a Cisco switch with VLAN 10 configured, and there's a web server sitting on it. And then the native VLAN is VLAN 1, which 90% of switches I see are VLAN 1 because that's how they ship, and people just plug them in and use them. Oh, I know why that's like that. I have an external video, and hopefully we don't have to fight with it here for it to show. That's showing up all right. All right. So there's a bunch of different tools for this. I'm using one called Frogger. Basically, it's going to sniff the network, and it tries to locate VLANs and different subnets on the network. So the network that I'm on right now is a 192.168.1.x network. VLAN 10 in this case is a 10.10.100.x network. And this does take a little while to run, and I didn't really speed it up much. Oops. Stop trying to pass through this. Alright, just bear with me, because obviously if I try to fast forward, it's going to blow up. So basically what's going to happen here is it's going to identify what VLANs are on the network. It'll identify sometimes it can identify the network range. Most of the time it can. And then it'll actually, the script will ask you which VLAN you want to hop to and ask what IP you want to give yourself on that network. And then it'll show that you're able to access that web server. And I think it actually fast forwarded. But you can see that it was able to get on the 10.10.100 network. And I'm going to set up a new interface on VLAN 10 with the IP 10.10.100.10. And it creates a sub-interface, ETH0.10, with that IP. And now I'm able to ping the web server, which sits at .100. And if you open up a web browser and browse to it, because it was a web server, 10.10, 100, VLAN on. So, I forgot to show that I couldn't ping that before, so I'm actually going to do a shutdown on the sub interface to show that I wasn't able to ping that before I started the demo. But there's my local LAN, and there's the hopped VLAN. And then I will do a shutdown on the sub interface, and I'll show that I can't ping over to that hopped VLAN. So you can see the ping is dead. So that's the hopping VLANs thing. All right. Mitigation. Disable trunk auto negotiation. Disable the dynamic trunking protocol if you don't need it. Change your default VLAN, your native VLAN, to something that you aren't actually using. So if you use 999, when somebody connects to the switch, they're not going to be able to. There's not going to be anything on that native VLAN. And yeah, don't put any devices on the default VLAN. Leave that default VLAN kind of as your unused zone, and assign ports on your switch to the VLANs they need to be on, versus allowing the switch to do it for you. And my last demo here, my last section, is local multicast name resolution and NetBIOS name service spoofing. This is actually used as a backup to DNS in a lot of networks. So if DNS resolution fails, the machines will actually ask each other if they know. If you ask for a system print server or a web server, they'll actually ask each other if they know where that lives on the network. It's enabled by default, so that's why people set it up that way. So the attack basically listens for connections and responds back if it's to the target. So if you were looking for, if you typed in web server, how many times have you tried to browse to a UNC path and typed the wrong thing? You fat fingered it, you added an extra letter, you forgot the name of it. So just as an example in this demo, if the actual server was called WebSRV and you typed in WebSRVR, my machine will respond back and say, oh, I'm WebSRVR. And you actually end up sending your hash credentials for the domain to the attacker, which can then be decrypted. So I will do one more demo here. So I just ran the script. This one's called Responder, is the name of the script. And it basically sets up it'll actually proxy all the connections, and it sets everything up for you. And I actually will put, these slides will all be on my blog at some point with all the tools and the notes and all that stuff. So now you can see I'm on a client machine here, and it's kind of cut off, but basically I'm just showing that I can get onto the internet. My connection is still working. And if I browse to what I browsed to was that web SRVR that didn't exist, and that's actually the hash that was given to me from the client. So that's the test user domain credentials, basically. So you could run that through John the Ripper. You could run it through, Hashcat, any tool that you want to run it through, and try to crack it. You may not always get it if it's a really secure password, but there's definitely potential to. And I was just showing that it outputs the hash in a nice file for you that's easy to get to later. Mitigation, disable LLMNR and NBT-NS. If your DNS is working properly, you most likely don't need them enabled. There probably are some cases where people need to have them enabled if you've got legacy systems, anything like that. But for the most part, people don't need them. Segment your workstations and user LAN from each other. It'll make, if you can segment machines from talking to each other as much as possible, it's going to make the attack a lot less effective. If you're not able to, if you have machines that don't need to be able to access your file servers and things like that, they're not going to give out credentials to sensitive information. And run as low privileged accounts. It's not a big deal if you have a test user not a test user, but a restricted user that gives up its hashes, and you're able to access that user's stuff depending on what they have access to. But if you're a domain admin and you give out your hash to an attacker, and then they're able to crack that password, that's a whole nother story and a whole nother problem. So that's kind of my talk and my 5 examples. I could probably go on forever with different examples and things that I've seen, but those are pretty prominent. And that is pretty easy to disable. You can go in the registry and set up a GPO to disable those 2 services. And you want to disable both of them, because if one's not available, it will fall back to using the other one. So if you disable LLMNR and you don't disable NBT-NS, they'll fall back to each other. So you want to make sure you disable both of them if you can. Again, all of the slides, and I'll have a list of tools and resources for any of the stuff that I talked about in here up on my blog, which is up at Overflow Security. I hang out in Freenode IRC in Overflow Sec, which is we have a little CTF team, and we run that blog, and we create some virtual machines for Long Hub and some custom tools. There's a few different things we've written on there. So check that out, and yeah, shoot me an email. Catch me after this if you have any questions. Anybody have any questions for me now?
Well, referring back to your slide about the local administrator password.
Yeah.
I'm not sure if you found out recently, but Microsoft released a free solution. Basically a password manager for the local admin.
Oh, yep.
Password, and it lets you set unique random passwords for each
system. Yep.
I
didn't hear about that, actually. I know that there's third parties, like I said. I think actually Trusted Sec might have released a tool too to do that, but okay. I'll have to check into that.
And then the second thing I was going to ask about was VLAN hopping.
Yep.
Is really all you need to do to prevent VLAN hopping, people arbitrarily setting IP addresses in different VLANs, is to disable that dynamic trunking? You
want to disable dynamic trunking and also change your native VLAN.
Okay.
Those 2 things will make a huge difference. I would never say you're 100% going to stop it, but that's those are kind of the two things that I recommend.
Are there any other additional things you can think of that help with securing and segregating VLANs?
If you've got layer 3 switches, access control. I mean, control what if people don't need to get to it, don't let them get to it. The more you can lock it down and control the traffic going through your switches and things like that and through your network, the better off you are. Anybody else? Go ahead.
There's a packet fence and other MAC address filtering kind of stuff you can do also, so that you limit the range of MAC addresses that are
Yeah, you can assign MAC addresses to the ports, and then that doesn't 100% stop it because you can spoof MAC addresses too.
Right, it's just sort of
adding
another
more
layer.
layers.
Yeah. Go ahead.
On the SQL Server
Yeah.
exploits, you had a bullet point of auditing SQL Server changes. Do you have recommendations for doing that?
I don't. I'm not a programmer, and I'm not quite into security as a career path yet. I'm hoping to at some point. I know that Nessus actually has some code audit and config audit stuff. I don't know as far as change control goes in that. And if anybody has any suggestions for them, feel free to speak up.
There's a really nice PowerShell scripts that people have for auditing your SQL Server environments. I think it's like TechNet blog.
So there's a TechNet blog with PowerShell scripts that you can use.
It's pretty comprehensive.
Awesome. Yeah, I mean, keeping track of the changes made on your application so you can, have somebody check over that and make sure they didn't just introduce a vulnerability. I've seen a lot of user input not being sanitized before it's sent to the application, and that's where you get in trouble with SQL injection, things like that. Anyone else? Go ahead.
How many organizations do you see protecting against ARP cache poisoning?
I live in Maine, so we are not the mecca of technology. Let me just put it that way. Zero. I haven't seen any clients with any protections for ARP poisoning. I'm sure in Boston there's a lot more around here, but I live in Maine, and if people can get on Craigslist and search for a new truck, they're happy. So.
What are some protections for ARP poisoning?
Probably MAC filtering would be one of them that would work. Controlling what's on your switch again, and that's a huge recommendation that I give to anybody is just know what's on your network. I don't know how many times I found web servers on networks that they didn't know about because somebody in accounting spun one up and wanted to play with WordPress. Well, now you just put WordPress on your network with a vulnerable plugin, and I had fun with that. But so just controlling what's on it. I'm sure there's commercial tools that monitor it for you. Intrusion prevention and detection systems. Some of them you can, run internal traffic through. It all depends how you set it up. But
does disabling gratuitous ARP traffic help with that, or is that something unrelated to different ARP?
That's a really good question, and I don't know the answer to it.
Yeah, ARP inspection and DHCP inspection, I think, are the two configurations you can do.
Okay.
Anyone else? Cool. Oh, no. Okay. Cool. Thank you very much.